Question number 5. Let's comprehend. Let the function f and g be defined by this. Fx is equal to this and gx is equal to this, where bracket x denotes the greatest integer less than or equal to x. So what is given? Two functions f and g are given. Now f of g, composite function, is defined. Usual definition. Suppose C is the number of points in the interval -1 to 1, which is the domain of both f and g, at which f of g is not continuous. So C is the number of points in the interval at which composite function is not continuous. And suppose D is the number of points in the interval at which f of g is not differentiable. Okay. What is asked? The value of C plus D. So I have to check the number of points where f of g is not continuous and number of points where f of g is not differentiable. Let's analyze. I recall the definition of f of g, NCERT definition, same. Now modulus of fx, we know that is equal to fx when fx is non-negative, and modulus of fx is minus fx when fx is negative, less than 0. And if a real number x, any real number x is in between integer and next integer. So if x is greater or equal to I and less than I plus 1, we know the bracket x, greatest integer value, is equal to I is integer. Now definition of continuity. At a point at x equal to c, a function fx is continuous if left hand limit at c, right hand limit, they are equal and equal to the value of the function. Differentiability. Now if a function is continuous at x equal to c, then the left hand derivative is equal to right hand derivative and it should be equal to some finite value. Then we say function is differentiable at x equal to c. So basic definitions from NCERT. And also we know that if a function is discontinuous at a point, then it cannot be differentiable. Now I recognize the function f is this. So we have modulus here. So we need to simplify the modulus here. So here inside the modulus it is 2x minus 1. The expression 2x minus 1 is changes its sign at x equal to half, and 2x plus 1 changes its sign at x equal to minus half. Means 2x minus 1 is positive if x is greater than half and negative when x is less than half. Similarly this. So we break the values. Domain is -1 to 1. So from -1 to half, minus half, this is negative, this is negative. We get this. From minus half to half, from half to 1. Now we simplify this. We get fx simplified version. We have simplified the modulus here. The function g is greatest integer, x minus bracket x, which is actually a fractional part of x. So from -1 to 1, we simplify this. If x is from -1 to 0, greater than -1, less than 0, what is the value of bracket x? -1. And if x is from 0 to 1, what is the value of bracket x? 0. So we simplify this and we get gx equal to this. So I recognize the fx is this, gx is this in the simpler version. So f of g, in f, anywhere we have x, we will put gx here, here, and the value of gx should be satisfying this. So we got this. Now let's go ahead. Let's do this calculation part. So f of g is this, gx is equal to this. So gx can take two values, either x plus 1 or x, if x is from -1 to 0 or 0 to 1. So everywhere I have to check both the values. So here I'm taking gx equal to x plus 1 first. So gx, the value of gx should satisfy this. and the value of gx equal to x plus 1 is for these values of x. Now, second part, value of gx, x should satisfy this, and gx equal to x for these values of x. So next, same way, the next, same way. So this value will be where? When x is this or this. So I have to check the common value of x here. So let's first simplify this, and then we have to take the common values of x, means intersection of x. So we got null set here, here minus 1, 2, minus 1, 0 to half, minus half to 0, and half to 1, and the value of expression f of g in different values of x. So finally we got this gx f of g. So this is the expression function f of g, and I have to check the continuity and differentiability at points. Now at x equal to minus half, it has different expression, less than minus half and greater than minus half. At 0, it again changes its expression, and again at half. So different expressions at minus half, 0, and half, and in this interval it is algebraic. So in the interval minus 1 to minus half, it is continuous and differentiable. Minus half to 0, in between them, it is continuous and differentiable. We know that the algebraic expression is differentiable and continuous everywhere. So I have to check the continuity at these points. So let's check. When at x equal to minus half, left hand limit, x is less than minus half, so f of gx expression is 2, limit approaches to right hand limit. If x is greater than minus half, we look here, 4 tending to minus half plus 4, that will be equal to 2, and the value 2. So left hand limit equal to right hand limit equal to value of the function. So it is continuous at x equal to minus half. Same way, we check at x0. Left hand limit here it is 4, right hand limit here it is 2. They are not equal, so function is discontinuous at x equal to 0. Same way, at x equal to half, we get it is continuous at x equal to half. So c is equal to 1, number of points where it is discontinuous. Now look at the differentiability. So I differentiated expression. So when we differentiate it, like we have in the piecewise, in the different interval, different expression, so I have not included minus half here. Look here. Why we don't do that? Because we don't know whether it is differentiable or not, right? Same way here and here, right? So we got this, and we are not sure about the value of minus half, 0, and half. X equal to minus 1 here, at x equal to minus half, LHT is this, 0, RHT is 4, not equal, so not differentiable. At x equal to 0, function is discontinuous, so we don't need to check differentiability, it is not differentiable. And at x equal to half, left hand derivative is 0, right hand derivative is 4, so not differentiable. So value of d is 3. Thus the value of c plus d is equal to 4. I got the answer. Basic result, basic approach, straight simple approach. No trick, no complication, no mystery. This is my approach. Straight simple approach, SS approach. No trick, no complication, no mystery. My name is Shishir Saini. I am graduate of IIT Roorkee, class of 96. IIT JEE coach since 99. Thank you.